The topic of this problem is mesh analysis, and we're working with circuits with independent sources. The problem is to find the current I sub 0 in the circuit shown below. We have a circuit where I sub 0 is the current which is passing through a 4 kilo ohm resistor at the top of the circuit. So the first thing we do when we're performing mesh analysis on a circuit is we assign the meshes or loops, and we assign the mesh currents. So I'm going to assign my meshes in the clockwise direction and assign mesh currents I sub 1, I sub 2, and I sub 3. So when we're doing mesh analysis, we know that we're using Kirchhoff's voltage law as a way of determining the mesh currents. So the result of mesh analysis is the mesh currents, or the mesh currents, in this case I1, I2, and I3. When we're looking for the current I sub 0 in this problem, we know that I sub 0 is going to be equal to what we have now designated as I sub 2. So we can find I2, then we know what the solution to the problem is. So the first thing we do is we start looking for I1, I2, and I3. And we notice that in our first loop that we can immediately determine I1 because it is the only loop or mesh current that's passing through our current source, our 2 milliamp source. So our first equation from our first loop is simply going to be I1 is equal to minus 2 milliamps, since it's flowing in the opposite direction of the way I1's been designated as flowing, which is clockwise. If we look at loop 2, we can sum the voltages up around loop 2, and we can use Kirchhoff's voltage law to do that. So starting at the lower left-hand corner of this loop or mesh, we first encounter the 12-volt source, and in fact the minus or negative polarity of that 12-volt source. We continue and we encounter the 2 kilo ohm resistor. We know the voltage drop across the 2 kilo ohm resistor is going to be 2 kilo ohms times I2, which is flowing the same direction as we're summing the voltages, minus I1, which is flowing the opposite direction. So our second voltage drop is the 2 kilo ohm resistor, I sub 2 minus I sub 1. Then at the top, as we go through the 4 kilo ohm resistor, we have another voltage drop, which is simply 4K I2, because I2 is the only loop or mesh current flowing through it. And then we get on the right-hand side of this loop, and we encounter the 6 kilo ohm resistor, and we know the voltage drop for that is going to be 6K I2 minus I sub 3. And then we get back to the starting point of our loop, and that sums up all of our voltages, and they're equal to 0. So now we have an equation which has 3 unknowns in it. We have a first equation where one of those unknowns is found for us by using our circuit analysis skills. And so we're going to look at loop 3 next. And again, just like loop 1, we notice that loop 3 gives us the loop current directly. Namely, I sub 3 is equal to 4 milliamps. So we know I1, we know I sub 3. We could plug both of those into our second equation, and we can find I sub 2. And so we find I sub 2, which we said is equal to I sub 0, is equal to 2.67 milliamps.